Hello everyone, this is the Finite Semester 1 exam review. Problem number 1 says identify the statement as true or false. So it says to do that, Illinois is one of the United States if and only if Wisconsin is one of the United States. They're both true. It's true if and only if true, and when they are both happen like that, then you have a true statement. So the answer is true for number 1. Number 2, solve the problem rounding the answer as appropriate. Answer. Assume that pure dominant describes one who has 2 dominant genes for a given trait. Pure recessive describes one who has 2 recessive genes for a given trait. And hybrid describes one who has one of each. So we have 2 hybrids that produce a litter of 4 offspring. What's the probability that exactly one is a pure recessive? So to do that, we've got, we'll have a dominant, recessive. And since so the outcomes could be dominant, recessive, another dominant recessive, and recessive. The probability that there is exactly one pure recessive, well, out of the 4 possibilities, there's only one that is pure. So the probability of pure let's back that up. Pure recessive, not pure dominant, is 1 out of 4. Because there's 4 options altogether. Number 3, we want to find the slope of the line. Slope is represented by m. That's the difference in it's true, it is the difference in the y over the difference in the x. But we already have an equation for a line, so to find slope, let's put it in slope-intercept form, which is y equals mx plus b. And we're looking for the coefficient on x. That's going to be our slope. You're just going to solve for y. So subtract 5x. That gives me negative 3y equals negative 5x minus 48. And then you're going to divide by negative 3. Y equals negative 5/3. Negative 5 over negative 3 minus 48 over negative 3. This is where your slope's going to be. Negative 5/3 simplifies to negative 5 over negative 3 simplifies to 5/3. There we go. So your slope is 5/3. Number 4, a line that's perpendicular to the equation. First we want to find the slope of the given line. So we're going to do the same thing that we did in problem 3. Put it in slope-intercept form and find the slope. I'm going to add 5x to both sides, so that gives me 3y is equal to 5x minus 26, and I'm going to divide by 3. That gives me y equals 5/3 x minus 26 over 3. So the slope of the given line is 5/3. The slope of a line that's perpendicular to that is the opposite reciprocal, so it's going to be negative 3/5. And that's all we needed was the slope of the line. For number 5, we also need the slope of the line, but we can use that using the concept of rise over run for the slope. I always start at a point that is that I know that's on the left side. So if I've got 2 points, I start with the one on the left. And then I'm just basically following the directions to get to the point that's on the right. So I'm going to go down 6 units. And I'm going to go to the right 5 units. Back up a little bit, I guess I'm going down 5. The 6 there was a little sneaky. So down 5. And I'm going to go to the right 5, positive 5. And so the slope of that line is negative 1. Number 6, we're going to do a little probability. The distribution of Bachelor's of Arts degrees conferred by a local college is listed below by major. And so we have English, math, chemistry, physics, liberal arts, business, and engineering. And it says, what's the probability that a randomly selected degree is not English? So we actually have a total here. That's all of them. That's going to be our denominator in our probability. And we want the ones that are not English. So a quick way to do that would be to take your total and subtract the number that's English majors. Which is 7,240. And then you can simplify that. You can make that a decimal as well if you want to. The decimal approximation for that is about 0.7774. So that would be the probability. Okay, number 7, it says the sizes of two matrices A and B are given. So they're both 3 by 3s. Find the size of the product AB and the product BA wherever these products exist. So A times B. So A was a 3 by 3 and B is a 3 by 3, and we look at the inner two to see if we can take the product, and then the outer two will be the size. Since we have the same dimensions, or our square matrices, whether you do AB or BA, the result is still going to be a 3 by 3 matrix. Number 8, find an equation in slope-intercept form where possible for the line. Slope-intercept form is y equals mx plus b. And sometimes you can go straight to that, but sometimes you need the equation point-slope form, where you're given a point and a slope, and then you can go into slope-intercept form. We have y minus y1 equals m times x minus x1. So that's point-slope form. For number 8, I would probably use point-slope because I have a point and I have a slope. So y minus y1 equals m times x minus x1. So minus a negative 13 is going to be plus 13. And then I'm going to simplify that and solve for y, and that's going to be in slope-intercept form. So y minus 7 equals negative 2x minus 26. I'm going to add the 7 to both sides, and I get y equals negative 2x minus 19. Now for number 9, I'm also going to use point-slope form, but I have to find the slope first. I have 2 points, so I'm going to find the slope. M equals y2 minus y1 over x2 minus x1. So let's see, negative 8 minus 3 over negative 2 minus negative 2 is plus 2. And I get negative 11 over 0. Well, that's an undefined slope, and that when I have an undefined slope, that tells me I have a vertical line. What that means for us is that there's not going to be a y defined there. The equation is going to be in the form of x equals, because it goes through the x-axis, vertical lines do, and then I'm just going to look at, I've got 2 points with the same x-coordinate, so my line is going to go through x equals negative 2. Number 10, again, point-slope form, but I need to find my slope, and it's perpendicular to the given line. So I've got to find the slope of this line, and then what the perpendicular one would be to that. So I have 9y equals 5x minus 66, and then I'm going to divide by 9. So my slope is 5/9, but I want the one that's perpendicular. So the perpendicular slope is the opposite reciprocal, so negative 9/5. And now I would take my new slope and my point and put it in point slope form. And then solve for y to have in slope intercept form. Number 11, find the probability of the given event. I have a single die, so only one, there's not two, just one, so numbers 1 through 6. And what's the probability that the number on the die is not a 6? Well, I've got 1, 2, 3, 4, 5, 6 numbers. 5 of them are not a 6, so my probability of not a 6 is 5 out of 6. On 12 and 13 it says find an equation in slope-intercept form where possible for the line. Those are the same kinds of problems that we had just a couple of seconds ago. This time you're given point, so you have to find the slope first. Then you're going to put it in point slope form and solve for y to have it in slope-intercept form. 13, you have a point and a slope already, so you don't have to go through to find the slope. Number 14, graph the feasible region for the system of inequalities. So we're going to graph that. You have a graphing calculator. You can use Desmos if you want to and just show me what that is going to look like. Okay, so I went ahead and graphed them on Desmos for you, and you can see what the graphs are going to look like. And what I would do is I would plot the first one and show where it has major points. It intercepts the y-axis at 1 and the x-axis at 0.25. And then I would look at the second figure, the second equation, and see its x and y intercepts and graph that. And then you can see the overlap, and you should see the solution is where they intersect. I mean, it's not just where they intersect, it's where the shading overlaps. So we're looking at this much darker part here. And so all of this would be my solution. So that's for number 14. Okay, I'm going to go ahead and graph 15, and you guys can see what that one looks like as well. Alright, here's my problems for number 15. I graphed the first inequality, and that's the red one. It has the solid line, and you can see that it has a y-intercept. It'll let me do it at 3 and an x-intercept at -2. And then I want to look at the second equation, or inequality, and it's just a vertical line that goes through 1. So I'm going to graph that. My solution then is this dotted region and the solid line and the shading right here. So that's my solution. That's what I want to keep. Alright, number 16 says use any method to solve the system of equations. So you can't use graphing for this because we have 3 variables, but the coordinate plane only has an x and y. So we can't use graphing for that. We could use matrices for this. It's not completely necessary, but to do matrices, what we would do is we would take the coefficients of the x, y, and z. So that would be 1, -1, and z, and 1. And then for the second equation, we'd have 1, 1, 1, Third equation is 1, 1, negative 1. And so if you remember, that would be A, okay? And then times our variables, x, y, and z. And that equals, and whatever the equations equal, that's going to make what's B. And that's negative 10, negative 6, and 4. If it'll let me write a 4. Okay. So in order to do this with a matrix calculator, what we would do is we would say that x equals, and those are going to be our x, y, and z, A inverse B. Okay, so what I did is I opened up a matrix calculator online. This is the Math is Fun matrix calculator. Probably the easiest one to use. And we want to do A inverse B, remember. So the A matrix is 1, negative 1. Looks like I'm going to have to delete as we go. The second one is 1, 1, 1. And the third row is 1, 1, negative 1. Note, if you just hit the tab button, it works better. Alright, so for B, that's actually what it equals. So that's at negative 10, negative 6, and 4. And so that becomes a 3 by 1 matrix. And just using the slider, you can change the size of your matrix. So I have negative 10, negative 6, and 4. And what I want to do is I want to do that A inverse B. So I'm going to do A inverse, which I did, and I'm going to send that to A. I'm going to put that in the A matrix, and it's going to replace that for me. That's the nice thing about this. And then I can just take A times B, which is going to be the same as taking A inverse times B. And then hit the A times B button, and there's your outcome. And so that tells me that 3 is your negative 3 is your x, 2 is your y, and negative 5 is your z. So, and it's ordered triple, negative 3, 2, negative 5. Alright, number 17. It says write a negation for the statement. We're not changing only the statement any, we're just changing that inequality. So if 7x plus 3y is not less than 7, then it's greater than or equal to. It's not the opposite. It's not like it's not just greater than. You have to include greater than or equal to. So my answer would be 7x plus 3y is greater than or equal to 7. Okay, I'm just doing number 18 kind of on a separate spot there so that we have plenty of room to work. It says Wally's Warehouse sells trash compactors and microwaves. Wally has space for no more than 98 trash compactors and microwaves together. Trash compactors weigh 28 pounds and microwaves weigh 51 pounds. Wally is limited to a total of 6,600 pounds for these items. The profit on a microwave is $93 and on a compactor is $21. How many of each should Wally stock to maximize his profit? So I'm going to start with that. He's going to maximize his profit. And so obviously we need to know how much Wally makes. And that's going to be a max function, so I say Z. I'm going to make 93 X, so X is going to be my microwaves, plus 21Y. And Y is going to be my compactors. And so let's make a note of that over on the side. X is my microwaves, and Y are the compactors. Then I need some constraints based on what I've got written here. Wally has space for no more than 98 trash compactors and microwaves together. So the number of X plus the number of Y has to be less than or equal to 98 because he can have no more than that. The trash compactors weigh 28 pounds and the microwaves weigh 50 pounds. And Wally is limited to 6,600 pounds of these items. So 28 X for the weight of the microwaves. I'm sorry, let's back that up just a little bit. 28 is actually for the compactors, so be careful when you're reading it. 28 Y plus 51 for the microwaves, which was X. And he's limited to a total of 6,600 pounds, so it has to be less than or equal to that value. So what I want to, now I do know that he's going to have a positive number of microwaves, so that's going to be greater than or equal to 0. And the compactors are going to be greater than or equal to 0. So what I want to do is I want to use Desmos. I'm going to graph my constraints. Those are my inequalities. And I'm going to try to locate my corner points. Whatever my corner points are, that's where I'm going to find my maximum values. And so I would put them into the Z function to find out which one gives me my max profit. Alright, so I actually put these on Desmos, and kind of the dark pinkish purple section there, that triangle of values, those are my corner points, and I'm going to substitute those into my objective function and see which one gives me the maximum value. My objective function was Z equals 93 X plus 21Y. And I want to try, now honestly, you don't really have to try 0, 0 out. We know if I put 0 in for X and 0 in for Y, he's not going to make any profit because he didn't sell any items. So I am going to try out, however, 0, 98 and 98, 0. And so I'm going to put that in for Z. Obviously I'm going to have 0, 93 times 0 is just 0. And then 21 times 98. And I'll get that value. And then I'm also going to do it for 98, 0. Which is going to be 93 times 98. Plus 0. Obviously, the largest amount is going to be when he purchases the microwaves. So that he can maximize his profit potential. So he's going to have 98 microwaves and 0 compactors. Okay, on number 19, we've got a similar problem where we have to find the maximum value of an investment. It says Zach is planning to invest up to $50,000 in corporate and municipal bonds. The least he will invest in corporate bonds is $6,000, and he does not want to invest more than $29,000 in corporate bonds. He does not want to invest more than $32,942 in municipal bonds. The interest is 8.1% on corporate bonds and 6.1% on municipal bonds. This is a simple interest for 1 year. Interest is the principal times rate times time. So that's kind of important to know for this one. So let's look at our constraints. Well, actually, let's define our variables first. I'm going to let X be the corporate bonds and Y be the municipal. And he tells us that for the corporate bonds, he wants to invest at least $6,000, but at most $32,942. And for the municipal bonds, he wants to invest at most $29,000. Well, we know he has to invest at least $0. He can't invest negative amounts, so we'll put a constraint of 0 on that as well. And then combining the two, his maximum investment is going to be $50,000. Now the tricky part to this is figuring out what the optimum function is. And so he wants to maximize the value of his investment. So when we're talking about value investment, we're talking about what he invests plus the interest. So he invested X dollars in corporate bonds, and on top of that, he received 8.1% interest for that. So that's 0.081. So that would represent how much he earned in corporate bonds, or how much it's worth now. And a similar thing with municipal bonds. So here's how much he invested in municipal bonds, and then he received an interest of 6.1%, so that's 0.061 times his investment. And so I'm just going to simplify that a little bit for my maximum function. And that's 1.081x plus 1.061y. So I really don't need that top one anymore. I'm going to put my constraints in Desmos, and I'm going to find my corner points, and then I'm going to put my values in for x and y in my maximum function. And this time I'm not looking for what my x and y are, but actually what's that maximum value. Alright, so I put in my constraints, and you actually have to zoom out a fair bit so that you can see everything. But I have, I'm going to close this a little bit so that you can see where the x's are limited, and then I'm going to throw in the y's there, and so now I'm in that little blue box, and then my next inequality, so that I have corner points at these locations. If it'll stay. Okay, so those are all my corner points there, and so I have several of them. And I'm going to put all of those into my objective function. The objective function was see if I can get it to write here. Z equals 1.081x plus 1.061y. And so I need to plug in my values. I think it took some of my ordered pairs away there. Gave me some extra ones that I didn't want. Okay, so those are my values. And obviously we want the largest ones, so we're looking at ones that have the biggest numbers. So probably going to be oh, it's not wanting to work with me. Let's see if we can get rid of some of these. So I think I can probably get rid of the 6,000 and the 29,000. That's not going to maximize my profits there. This one probably isn't either. So I'm really just looking at these two to substitute into my equation. So when I worked it out, I actually used this corner point here, and I got 53,708.84, which is a little bit slightly different than the answer key. Could be just a matter of rounding on that. You know, you see if you get a different answer for that one. But that's how you set the problem up. All right, on number 20, for that one we're just going to use Desmos. I'm going to plot my table in Desmos, and that's going to give me my scatter plot. And I'm going to ask it to make a line for me and graph that, and then I'm going to look at R and the correlation coefficient for that, and then we'll do a prediction to predict the Y value when X is 15. Alright, so for number 20, the first thing I'm going to do is to add a table of values, and I'm going to put my X's in, and my corresponding Y's. And then I want to do a line of best fit. So I'm just going to graph it ask it to do a line. So Y sub 1, and then MX sub 1 plus B. I might have to zoom out a little bit to see our points, but there's our points, and you can see that they do lie along the line. And then I have my R there. My R is 0.95. The closer that number is to 1, the better the equation represents my data. So that's pretty good. It's awfully close to 1 there. So my correlation coefficient, which is R, is 0.95. And it wants to calculate the least squares line. I'm just going to put these values in for M and B. So my equation would be Y equals 1.7x plus 7.5. And then I want to see what Y is when X is 15. There's a kind of a sneaky trick. If I put another line here and I just say X equals 15, wherever that intersects my equation is going to be my solution. So when X is 15, we find that Y is 33. So A, my scatter plot, I actually need to graph the line before I find that correlation coefficient. And then that's my R. And then you can just put in x equals 15 and it'll give you your output, which is 33. Alright, for number 21 it says the Acme Class Ring Company designs and sells two types of rings, the VIP and the SST. They can produce up to 24 rings each day, using up to 60 total man-hours of labor. It takes 3 hours to make the VIP ring and 2 hours to make the SST ring. How many of each type of ring should be made daily to maximize the company's profit? And the profit on the VIP ring is $40 and on the SST is $30. I'm not going to do this whole thing for you, but I will help you get it set up. We're going to maximize. Okay, I'm going to let X equal the VIP ring and Y equal the SST ring. And so my maximum function is going to be 40X, because it's $40 for the VIP, plus 30X or 30Y for the SST. So that's my max, my optimum function. And then I need my constraints. Well, I know that I can't have negative rings, so I'm going to have X is greater than or equal to 0, and I'm going to have Y is greater than or equal to 0. I know that at most they can make 24 rings, so that's going to be X plus Y has to be less than or equal to 24. And I know that they only have 60 man-hours to work. It takes 3 hours for ring X, and it takes 2 hours for ring Y, and at most that can be 60. So there are my constraints. Again, you would put your constraints in Desmos. You're going to find your corner points, and the corner points are what you're going to put in your maximum function. We want to know how many of each type of ring this time. So we're looking for the maximum value, but we actually want how many rings we have to get that maximum value. So we're looking for X and Y in this case. Alright, number 22. We're going to write a cost function for the problem, and it says assume the relationship is linear. So we're making a linear function. A moving firm charges a flat fee of $30 plus $25 per hour. Let C of X be the cost in dollars of moving the moving firm for X hours. So cost is just the same. It's very, very similar to slope-intercept form. So we have our cost equals mx plus b. B is always your fixed cost, so that's the part that doesn't change. And then the m is going to be the thing that changes based on, in this case, your hours. So our cost function for this particular case is going to be 25x plus that $30 fee. So that's your cost function. Number 23, it says perform the indicated operations where possible. So all we're doing is adding. We're going to add parts that are in the same place. So if we've got row 1, column 1, we're going to add that to row 1, column 1 from the second matrix. Row 1, column 2 would be added to row 1, column 2, and so forth. And our matrices would be the same size. Now make sure that they are in order to get your sum. So we're going to do 1, 1 and plus 1, 1 is 12x plus 4y. So that's going to be your first entry. And then row 1, column 2 plus row 1, column 2 would be 9x plus 3y. Row 2, column 1, you're going to add your x's, so 2x, and then your y's will cancel. And then row 2, column 2, you add your x's, you're going to get negative 10x minus 11y. And that's it. Number 24, same kind of thing. They have to be in the same location. Okay, so corresponding parts. This time you're just subtracting them, subtracting the elements for 24. 25, we're going to find the probability. It says each number each digit from the number 1,656,446 is written on a different card. If one of these cards is selected at random, what's the probability of drawing a card that shows a 1 or a 4? So we're not going to distinguish really between the two. How many 1s and 4s do we have is what we're looking at. So we have probability of 1 or 4. We have 3 of those. And we have 7 digits altogether, so my probability is 3/7.